Hello and welcome to my video on the conservation of energy. So to start with, the law of conservation of energy is right here. Energy cannot be created or destroyed, only transferred from one form to another. This is my wording of it, but it's basically correct. I'm sure it can be expounded upon, but other than that, it's generally the simplest way of explaining it. We cannot destroy energy. We cannot create energy out of nothing. We can transfer it from one form to another. Therefore, the total energies at the beginning will be the same as the total at the end if you just add up the totals on one part and the other. That is what it tells us. In our case, we often talk about a frictionless system in which a mechanical energy is conserved, meaning the total potential and kinetic energies at the beginning are equal to the total kinetic and potential at the end. Now this is really key. It's the addition of the kinetic and potential at the beginning plus equals the addition of the kinetic and the potentials at the end. Not that the kinetic at the beginning equals the kinetic at the end and the potential at the beginning equals the potential at the end. That's not what we're saying. We're saying the totals, the sum of them. The sum, the addition of them at the beginning equals the addition of them at the end. So we need to know that formula there, but we also need to have two other formulas in our back pocket. And these are ones that we have from before, so there's no big change here, but you need to keep these in mind moving forward. So EK, kinetic energies, are given by mv squared over 2, and EP is mgh. Alright, with those three equations, we can solve all of these types of questions. So let's take a look here at this question. So this says you swing across a river using a long rope. So I'm going to try to draw this situation out very basically. Alright, so maybe there's a tree or something that the rope is attached to, but you are over here. And then you swing down. Okay, and then you swing up to this final resting position. Okay, so hopefully that gives some idea of what this could look like. Now, what's actually going on? Okay, it tells us that the rope is 5.0 meters long. And it says that you obtain a speed of a velocity of 2.5 meters per second at the lowest portion of the swing. That's right here at the lowest portion of the swing. Determine the maximum possible height of the swing, i.e. we're looking for what is it compared to that lowest point, what is the height of the swing. Okay, so what are we looking for? We're looking for the height here. And to be entirely clear, that we're going to use this as VI. Whoops. VI, and this will be our HF. That's what we're looking for. So let's take a look. At the VI position, is there a height? No, there's absolutely no height at that position. At the HF position, is there a velocity? No, so we're going to actually ignore those two. And so we're able to go mvi squared over 2 equals mghf. Now what we're going to do here is try to use hf as purple the whole time so it's very clear. We're looking for that hf. So what we're going to do is we're going to divide by mg on both sides. So on the right side, that's the whole point of it is to move it over. On the left side, the m's do cancel, which is very nice. So that means HF equals, and then we have VI squared over 2G. Okay, with our VI being 2.5, so squaring that, and then 2 times 9.81. And so let's plug this into our calculator. we get 0.31855. Okay, but we've got 3 sig digs, so it should be 0.319 meters as our final answer for that one. All right, let's take a look at the next one here. Again, I always recommend pausing the video, trying it out for yourself, and then moving on. So hopefully you've been able to do that. Here's the situation. There's a person on top of a diving board, diving platform, whatever. There's some water down here, and they're jumping down. It tells us the height of the diving platform, which I'll call the initial height. And when they jump off, they are jumping until the point where the height is now 2.35 meters. So what is the velocity at that point? Well, let's cross off what we know. Our initial velocity is 0, so we can cross off that first aspect here. Initial velocity is 0, but the rest of this stuff we all need, so let's go ahead and start writing it in. Alright, so we're looking for that VF here, but we have everything else, so what we're going to do is we're going to move stuff over and get VF by itself. So always the rule is opposite order of operations, opposite bed mass. So with that said, the first thing we have to do is add and subtract. So we're going to subtract by mgHf on both sides. So that cancels here. And so we're left with mghi minus mgHf equals m, like this, VF squared. There you go, just like that. And so now what we have to do is move the 2 and the m over. So always with opposite order of operations. I always say do sections at a time. So always do addition, subtraction, then division, multiplication, then exponents, then brackets. So we already did addition, subtraction. That was our first step. Now division, multiplication. So we're going to multiply by 2, divide by m. So 2 over m, like this. So that cancels here and here. So now all these m's are actually going to cancel as well. So this side ends up being 2g, and then I'm going to factor out the g. hi minus hf, and then equals, we're going to have vf squared. So again, we're just trying to get the vf by itself. That is the whole goal of this. So now we're going to square root this, and so now we're going to have so those are going to cancel there, and so we're going to be left with VF, sorry about that, equals square root of 2g hi minus hf. So 2 times 9.81 times by hi, which was 10 meters, minus hf, which was 2.35 meters. And so that's going to give us, and so I'm just going to write all of this in my calculator, 2 times 9.81, 10 minus 2.35. So this equals 12.25 meters per second. So keeping in mind that our mass did not affect this one bit, so it's actually going to be 3 sig digs, so 12.3 3 meters per second as our final answer. All right. I'm going to stop there. Those were two slightly more basic examples. The first one with just 2 different types of energy. The second one with 3 different types of energy. I recommend trying this out, and in the next video, I'm going to do this example. Good luck.